So for this implicit differentiation, then finding the second derivative, so take note that for every derivative of y, there must be a y prime. So if we have y to the power 3, so this is equal to 3y to the power 2. So minus 1 for the exponent, then there must be a y prime. Then for 4y to the power 2, so multiply this 4 and 2. That's 8y, so minus 1 for the exponent. Then there must be a y prime. So for this given, to find the first derivative, so we just need to derive every terms. So for the derivative of x to the power 2, this is 2x, then minus 2 times the derivative of x times y. So using the product formula, so this is x times the derivative of y, then plus y times the derivative of x, that's 1, then plus, so for the derivative of 3y squared, so multiply these two numbers, so this is 6y, then times y prime, then equals the derivative of a constant, this one is 0, then to simplify, so we have 2x, distribute, so negative 2x times y prime, then distribute, this is negative 2y, then plus 6y, then y prime equals 0. Then to solve for the first derivative or to solve for y prime, so we need to group all terms with y prime on the other side. So we can transpose this negative 2x times y prime to the other side and this 6y times y prime to this side. So we have now 2x minus 2y then equals, so this negative 2x y prime becomes positive 2x times y prime, and this positive 6y y prime becomes negative 6y y prime. Then we need to factor out this y prime, so put this y prime outside. So we have now 2x minus 2y equals, put the y prime outside, so the remaining is 2x minus the remaining, that's 6y. Then to solve for y prime or the first derivative, so divide every terms by this 2x minus 6. So cancel. So therefore, the first derivative is equal to 2x minus 2y then over 2x minus 6y. Then observe, since these numbers are divisible by 2, so we need to reduce. So therefore, the first derivative is equal to x minus y then over x minus 3y. So this is now the first derivative. Then this time to find the second derivative from the first derivative. So we have y double prime equals, so this is the quotient formula. So if we have u over v, so this is equal to v times the derivative of u minus u times the derivative of v, then over v squared. So from this formula to find the derivative, so we have v, and v is the denominator. So this is x minus 3y times the derivative of u, so the derivative of x minus y. So the derivative of x is 1, then minus the derivative of y, that's y prime. then minus. So we have u, and u is x minus y times the derivative of v. So the derivative of x minus 3y and the derivative of x, that's 1, then minus the derivative of 3y. So this is 3y prime, then all over v to the power 2. So that's x minus 3y to the power 2. Then to simplify, so we have dy double prime or the second derivative. So multiply. So this is x. Then multiply. So negative x times y prime. Multiply. So this is negative 3y. Negative times negative. So we have positive 3y, y prime, then minus. So we need to put first the second group inside the parentheses because this one is minus. Then multiply. So we have x multiply. So negative 3x y prime. Then multiply negative y and negative times negative. So this is positive 3y y prime. Then over x minus 3y quantity to the power 2. Then we can simplify. So we have x minus x, then y prime minus 3y, then plus 3y y prime. Then distribute this negative. So this becomes negative x, then positive 3xy prime, then positive y, and this becomes negative 3y, then y prime, then all over. So we have x minus 3y quantity to the power 2. Then this time we can combine like terms. So we have this positive x and negative x. This one is 0. Then also this positive 3y y prime and negative 3y y prime. So this one is also 0. Then this negative xy prime and positive 3xy prime. So this becomes y double prime equals. So this is 1 and this one is 3. So negative 1 plus 3, that's positive 2. Then x y prime. Then for this negative 3 and positive 1, so this is negative 2. Then y, then over the quantity of x minus 3y, then to the power 2. Then this time, we need to substitute now the value of y prime. So we have this y prime using this equation. So we have now y double prime equals 2 times x times y prime, and y prime is equal to x minus y, then over x minus 3y, then minus 2y, then all over x minus 3y quantity to the power 2. Then simplify. So we have y double prime equals, multiply this 2x. So this becomes 2x to the power 2. Then 2x times negative y. So this is negative 2xy, then over x minus 3y minus 2y, then all over the quantity of x minus 3y to the power 2. Then we can use now the butterfly method in the numerator. So this is over 1. So multiply. So we have 2x squared minus 2xy. Then multiply. So this is negative 2y times x minus 3y. Then over. So multiply. So this is x minus 3y. Then over the quantity of x minus 3y to the power 2. Then to simplify, so we have this y double prime equals, so this is 2x to the power 2 minus 2xy. Then distribute, this is negative 2xy. Then this becomes positive 6y squared, then over. So this x minus 3y, then times the reciprocal of this denominator. So times 1, then over x minus 3y quantity to the power 2. Then this becomes 2x squared. Then this negative 2xy and negative 2xy. This is negative 4xy, then plus 6y to the power 2, then over. So this becomes x minus 3y quantity to the power 3. Then observe in the numerator, so we can factor out 2 because all these numbers divisible by 2. So we have y prime equals, so we need to put 2 outside, divide by 2, this is x squared, then minus 4 divided by 2, that's 2xy, then plus 6 divided by 2, that's 3y squared, then over the quantity of x minus 3y to the power 3. Then observe that this equation x squared minus 2xy plus 3y squared is equal to 4. So therefore this becomes y double prime equals 2 times 4, then over x minus 3y quantity to the power 3. So therefore the second derivative is equal to 8, then over x minus 3y quantity to the power 3.